Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, my name is Naima Rafika Rumjaya with the number K3323056, and today I will show you how to characterize compound using FTIR, UV-DRS, SEM, and the last one is XRD. Okay, in this part, I will give a tutorial to characterize a compound with SEM. First of all, we must open image G. Okay, we click File and then Open. And then we choose our picture that we want to characterize. And make sure the format is TEF. And then we click Analyze, click Set Scale, and then in the non-distant, it's a 0, and then pixel aspect ratio also 0, and unit of length is pixel. We click OK. Then we measure this. Okay, we go back to the image G. We click Analyze again. Click Set Scale. Non-distant is 1000, and then unit of length is nanometer. Click OK. Then we click Straight. And then we measure all of the particle in this picture. Click Ctrl M and D. So we have the result of the data area. We do the same thing until the data is 30 until 50. Okay, we already have 70 data, and then we copy all this data to origin application. Okay, we copy all the data in this page. We give the long name, and the name is area, and then we block B column. We plot. We choose histogram, and then right click, go to bin worksheet. Okay, we block A and B column. We click plot, and then we choose column, and then we analyze this. We click fitting, and then nonlinear curve fit. We click open dialog. On this function selection, we choose pick function, and then in the function column, we choose Gaussian. Then click advanced. Make sure you choose quantities, click quantities, and then click fit statistic. Make sure the square code or COD is checklist checked. Okay, after add square COD are checklist, we click fit, click OK. Okay, we have R square or COD is 0.964 H and 9. Okay, the next one is characterization of compound using FTIR. First of all, I would like to copy data. This is the data that we want to use to characterization GTEMN. Okay, next copy the data in origin application, but before that, we can name a column with number, and the next column or B column with transmit times. This is the data that we want to use. The next step is block all the column, then click plot, click line, line again, and we have the data. To tidy up the graph, we must set up the scale. How to set up the scale? First of all, we must right click on the x-axis, scale. We set scale from 500 to 4000. Okay, and then click apply, click vertical. In this part, we set from 60 until 110. Okay, next we click apply and we click OK. So we already tidy up the data, and then we must give the line on the upper side and the right side. First of all, we must click right click and then scale. Click in light and text. Nah, on the top, we give the line, show line and text, checklist, and then for the style, we choose none. It's also none, and we click apply. Now we move to the right side. Click show line and text. We choose none again for the style, and another style in the minor text we also choose none. Okay, it's already done, and then we click OK. So there are lines in all the side of the graph. The next step is we must carry out the function of group in this graph. The way to determine the function group of the graph is, first of all, we must click screen reader in this left side. And we must give a sign in graph that shows a sharp peak. For the example, it's a sharp peak, sharp, and this is a sharp. All the sharp peaks, we give a number, or we give the function of group can see the number of the function group at the bottom of the screen. This x is 1156.74875. But next, 1156.7. Right click, properties, and then we rotate in 90 degrees. 90 degrees. Okay. Okay, we already finished. So we can change the name with compound that we used, and the name is ZTIMN. Okay, we can save the data. Now we want to try the characterization of FTIR using a different data. I will copy all the data first and paste in origin application. Don't forget to give the long name of a column as wave number, and then B column is transmittance. Okay, now we plot the column. Click plot, click line again, and then we have the data for GDIV. Okay, now I will tidy up the graph like before. We set up the scale. The way is same. Right click, scale, and I want to set the scale from 500 to 4000. Click OK, click apply, and then from the vertical, I'm gonna set it from 70 to 100, and then also click apply and then OK. Okay, this is the graph that we have. So like before, we must determine the peak that have sharp peak. As we can see on the graph, we can do like before. Click screen reader, click the sharp graph. First one is in this thing. Okay, the number of the function group you can see at the bottom of the screen, which is in here, x equal to 1199.86047, and this is a new value. Okay, do it the same thing on the another peak. And appropriate to the name of the compound. Okay, it's finished. Now we can save the graph and save the file with the same way as before. Copy all the data that we want to use in this characterization. Paste. Okay, we change the z-axis to x. Okay. Now I would like to copy another data. Okay, I already copied all the data that we want to use in this characterization. Now we block all the column. Click plot, line, line. Okay, this is the data that we already obtained with data before. Now I would like to do the same way as before to tidy up the graph. For the first, click scale, 500 to 4000. From the vertical is 60 to 100, and then also kinetics from the top. The style is known, and the minoritics of style is also known. From the left, also same, and for the right, we click show line index, and for the major ticks, we choose the style is known. From the minoritics, also known. Okay. Make sure you click apply, and from the line index, you must also make sure to click apply. After all the thing is done, click OK. And this is the graph that we already have. So right now, I would like to determine the function of groups for the red line first, and then I will determine the function of groups of the black line. It's from the red line. Okay, I already done, and this is the data and the graph and the characterization of FTIR that we have. Thank you. Okay, next we move to UV-DRS characterization. First of all, I would like to share my screen. Okay, we already have data to characterization UV-DRS. We copy all the data. Okay, we copy all the data and we must open origin application. Then we give the long name of our column AX is wavelength. For BY is absorbance. Okay, at some column, this is an halfway, and then the last column is F. FR halfway. For the effect in column JA, we set as X, and then we give in the effect is 1240 divide to A, and then from column J quadrat is B star B times C. Okay, next we copy the data from the Excel. This is the data that we have. Okay, next is log the column C and D. We just plot and then line and then line again. Okay, this is graph that we obtain. Okay, we will tidy up the graph with adjusting the scale. Choose the x-axis, right click, scale. Okay, from we try from 3 to 6. Okay, apply and then okay. For the y-axis, we try with 5.0, 0.5 until 2022. Apply and then okay. Okay, we have already have the graph. Okay, we have already obtained the graph. Okay, now we determine the band gap from this graph. This line. Pull up the line. Okay. Next, we choose this screen reader and then click on the bottom of the line. Okay, it's 5.0, 5.21. We choose the line and then to make it clear, we maximize. Okay, now we write the band gap is 5.0.1. Minimize. Okay, this is the band gap that we have. So that's all to UV-DRS tutorial. And then we can save the file, save as project. Okay, now we want to characterize UV-DRS with the different data. Okay, this is data that we got. Copy this data. We paste the data in origin application. We block NP, delete. Okay, now we paste the data that we copy before. Okay, we have this data. After that, copy C and D column. Click plot, click line, line again, and yeah, we have the data. So we want to tidy up the graph, and we can have appropriate scale. Okay, right click, scale. It's 3.5 until 6. Click apply and OK. Now y-axis, click, right click, scale. So 0 and 27. Click apply. Okay. Okay, this is the data that we got. So after that, we can determine the band gap from this graph. Click line tool and pull the line until the bottom of the x-axis. Okay. Now we choose screen reader and okay, it's 3.81. 3.81. 3.81. To make it clear, we can change the measurement 1.5 and then the color of the line. We try red. So this is band gap that we have in this data. That's all for me. So we can save the file. Okay, the next step, I want to give a tutorial how to characterize compound using XRD. Okay, first of all, I want to copy the data that I already have. In the long name, we give the name NEJO. Also in the B column, NEJO. In the units, in the AX column, we give 2 theta, and then on P column, we give intensity. In the next column, C and D column, we write GGPDS and E, and then in the units also to theta and intensity. Then copy the GGPDS and E that give it, and we only use the last 2 parts to all of the data. So we copy the last of the data into C and D column. We also doing the same thing on GCP-DAS-JO, and we use the last two data. After that, we change the axis of CE column into X, which is the units is to theta, and then click plot, multi-panel, stacked, and click OK. So we obtain the graph that we already have. Click on the bottom of the graph, and then in the connect we choose no line, and then drop line checklist the vertical and click OK. In second graph we also doing the same things, and then the last graph we click the box of the graph and then click analyzing, signal processing, smooth and open dialog. And the point of window we change into 30 and then click OK. Click the red line and then unchecklist the book 1. Then we have already the graph, and we can set up the scale to tidy up the graph. The most important thing is the graph look clear and the peak is sharp. The way is same. Click on the X or Y axis and then set the scale. After that, click Analysis, Peak and Baseline, click Peak Analyzer and click Open Dialog. In this part, we can choose Next, Next, and unchecklist the Enable Auto Find, click Add, and we can add into peak of the graph some line. We choose the peak that really sharp. We can choose the graph with 2 times of click. And then we can minimize the peak analyzer. Click OK. On the part of direction, we click positive, and then we can click next. And we click adjust on the preview graph. We can minimize the peak analyzer, and we can minimize the block of the graph into the peak that we already chose before, like in this picture on the screen. If it's done, we can choose finish. Next is click Project Explorer, and then we go back to the book 1, and we can choose the center of this data, and then we can paste into crystallinity Excel. For the next is FVHM, we can also paste, and we get the average crystal size. Okay, to get the big area of crystal, we copy the part of area and then we paste on crystallinity in Excel. So we have the size of crystal peak. Then we want to know the size of a whole crystal, so we go back to origin, click back on the graph and click analyzer. Pick and baseline, pick analyzer, and we do the same thing as before. Click next, uncheck list, click add. We choose the peak that we already chose before, the same peak. After all the peak being chosen, we click done, and then from the direction is positive, click next, and then click adjust on the preview graph, uncheck list all peak, and then the number of range to integrate we change into 1, and then click minimize. The difference is to determine a size a whole crystal, we drag the line from end to end of the graph, not only that we pick, we choose. So we have the whole size of crystal and its are moved. We can go back to crystallinity Excel, and then we can paste the area of the crystal, and then we have crystallinity of the crystal. So it's finished, and we can save and export the data that we use. Now we can try to characterizing the compound using different data. The way is same as before. We copy the data and then we can paste on origin. The difference is we have some ZN peak, and then we must use peak list of ZN. The way is same. We also use the last data from the data that we copy. In units, to theta we set from y into x. All the 2 theta we set from y into x. We block all the data, click plot, multi-panel, and then stack it. Okay, we already have the graph. We give the same treatment as before. Click 2 times on the graph, and then on the content click no line, drop line, vertical checklist, and then OK. From the graph that have decline, we can choose the bulk of the graph and then click analysis, signal processing, and then we choose smooth and open dialog, and then we change the point of window into 30, and then before that we click preview. On the red line we can uncheck list book 1 set 1 and then click OK. Then we can set the scale until the graph is tidy up, same as before. After finish, click Analysis, pick and baseline, pick Analyzer and open dialog. Same as before, click Next, 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 and then uncheck list the Enable Auto Find, click Add, and then we can choose the pic.sharp like picture on the screen. And then like on the screen we can choose the pic that we already get. We can shift the line like this, like on the video. Then we go back to the book 1. So we have the new data, copy the center, and then we can paste on the crystallinity in Excel. Then from VVHM also paste on crystallinity in Excel. So we have the average of crystal size. We obtain 3.7, and then to get big area, we copy area from the data, and then we choose and copy on the Excel. Go back to the origin because we want to know the size of whole crystal. We click on the box of the graph, pick Analyzer, and then open dialog. So we choose Next like before, same as before. Next, uncheck list the Enable Auto Find, click Add, and then we choose pic that we already choose before. It's the same pic. Maximize the pic analyzer, and then from the direction we choose positive, same as before. Click Next, and then we click Adjust on the preview graph, uncheck list all pic, and then we choose number of ranges to integrate into one. And the difference is we drag the line in the whole of the graph, not only the graph the pic that we choose, but in the whole graph. So we obtain the whole size area from the crystal. We can copy in the Excel, and now we get the crystallinity of the whole crystal. So in the end we can save and export the graph.
Okay, that's all for me. I hope it can help you to characterization a compound. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.